Okay, so we're going to start our probability unit, and these, this is probably a word you never heard before, but maybe you have. So we're going to talk about permutations and combinations. So our learning target is I can model and solve problems using permutations and combinations. Okay, so it's a little weird. We're just going to talk about some basic vocabulary and things like that. And then this is called the fundamental counting principle, which is probably things you've already done in elementary and middle school. So if decision M can be made M ways, and decision N can be made N ways, and those are just numbers, then the two decisions can be made M times N ways. So here's what I'm talking about. If you look at number 1, the ice cream shop offers 3 cone sizes, 15 flavors, and 8 toppings. And we want to figure out how many cones are possible if you can only choose 1 flavor and 1 topping. So here's what the counting principle says. If there are 3 different cone sizes, and there are 15 different flavors, and there are 8 toppings, then I just have to multiply them all together. So when you multiply them, you get 360. So there are 360 ways that you can choose 1 flavor and 1 topping. Okay, so this one is very similar. So Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are available? So here's what I'm going to do. Here's how many ways I could choose the first letter, the second letter, the third letter. So first letter, second letter, third letter. Okay, so there's 4 digits. So 1 digit, 2 digit, 3 digit, and 4 digit. So now we gotta think about all the possibilities. Like, there are 26 letters in the alphabet. So for the first letter, you have 26 possibilities. And then the second letter, there's 26 possibilities. And the third letter, there's 26 possibilities. If you think about digits, you're thinking about digits from 0 to 9. Count those up if you don't believe me. There's 10. So if we take all of these numbers and we multiply them together, it's a huge number. So 175760000. So that's how many different possibilities there are for Virginia license plates, and that's how you do these kinds of questions. Okay, so Nick's science test had a section with 12 true or false questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want to figure out how many different ways can Nick answer those questions. So think about true or false. There's only 2 options. You either pick true or false. For the next question, true or false. True or false. True or false. True or false. Alright, so now you're going to multiply all of this together, and we get 4,096. There are 4,096 ways that he could have answered that test. Alright, to enter their home, the Clayton family enters a 4-digit code. How many codes are possible? So there are 4 digits. I remember that there are 10-digit possibilities. So if we multiply all those together, we get 10,000. So there's actually 10,000 ways that they could do that. Alright, so that's your fundamental counting principle. Next thing we're going to talk about is something called a factorial. So a factorial looks like this. It's in like some number and an explanation sign. An explanation mark. That sounded weird. Alright, so a factorial is the product of all natural numbers. Natural numbers are just whole numbers from n to 1. So I know that doesn't make sense. So if you look at this one, the first example, 9 factorial, you would multiply 9 and all the numbers that are below 9. Alright, and if you multiply all those together, you get 362 800. And there's actually a button on your calculator. You can find it. If you're using a TI-84 calculator, if you go to the math menu, and then you right arrow over to PRB, which is probability, and then number 4 is your exclamation point. That's your factorial. Or you can just do what I'm doing, and you can just multiply all the numbers. So if you do 12 factorial, that's 12 times 11 times 10 times 9 times 8, blah, blah, blah. So you get this huge number. If you do 8 factorial, you get this big number. And if you do 0 factorial, that always equals 1. Okay, so not a big deal, but in case you ever see it, sometimes it pops up on the ACT, stuff like that. I just want you to have known what that means. Okay, so a permutation. Here's our first vocabulary word. Alright, so permutation is an arrangement or lineup of objects in which order matters. So say for instance you were voting for student council. The order is going to be like you're going to do president, then vice president, then secretary. The order is determined. If you were just going to select 4 people to be in a club, then order wouldn't matter. Okay, so here's the formula for permutation. It's n factorial divided by n minus r factorial. And I'll show you what I'm talking about in just a minute. N is the total number of objects available, and r is the number of objects to use for the arrangement. And we'll do some examples because I know that means nothing. So if you ever have a permutation and you're doing NPN, then you're really just doing n factorial. Alright, I know that makes 0 sense, so let's do this. How many ways can you arrange the letters in the word dinosaur? Okay, so order definitely matters when you're choosing this, because like that's just, I mean, that's how you spell words, because the way you put the letters makes a different word, if that makes sense. Okay, so if you count 1, 2, 3, 4, 5, 6, 7, 8, there are 8 letters total. This is a permutation because 8 matters, because the order matters. And then we're still going to choose 8 letters. So here's what this says. 8 factorial. And you can either do 8 factorial on your calculator, or you can do 8 times 7 times 6 times 5 times 3 times 2 times 1. And you get 4,320. Another way to think about this, and sometimes it helps people. Okay, so I have 8 letters. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 ways I could choose the first letter. But if I've already used the letter D, then the next letter only has 6 options. And I've already chose D and I, then the next letter will only have 6 options. The next one have 5, 4, 3, 2, and 1. And if you multiply that all together, that's the same thing as 8 factorial, which is how you get 40,320. So you can either do it this way, which is just the formula, or you can write it out if it makes more sense this way. Okay, so here's this one. 7 students are competing in a geography B. How many ways can they finish in first, second, and third place? So order matters because it matters who comes in first, who comes in second, who comes in third. They're not just randomly picking it. Alright, so there are 7 students. It's a permutation, and they are competing for 3 different places. So if I use the formula, I'm going to have 7 factorial on top, and on the bottom, 7 minus 3 factorial. So remember, 7 factorial is like this. If you don't have a TI-84 calculator, which you don't need, and on the bottom, 7 minus 3 is 4, so 4 times 3 times 2 times 1. So if I do this, I get 210 ways. Alright, Melanie is taking 4 classes this summer, so there's 4 total. It's a permutation. The classes are American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? So she has 4 total classes, and she's still choosing 4 different ways. So this is just 4 factorial, which is 4 times 3 times 2 times 1, and that's 24 different ways. Or you can think about it like this. There are 4 different classes, so she's going to choose one. Let's say she's already chosen American History, so there's only 3 options left. And then the next one there would only be 2 options, and the next one there would only be 1 option. So it's 2 different ways to think about these problems. Alright, number 8. There are 16 players. Permutation. We're going to see how many ways can you choose 9. So we're just going to use the formula. 16 factorial divided by 16 minus 9 factorial. So this one's a big number. There are this many ways to choose. Okay, let's do one more example. There are 28 students. How many ways can the students elect a student council representative and an alternative? So that's 2 ways we're looking at. So 28 factorial divided by 28 minus 2 factorial. So 756. Alright. So now we're going to look at permutations with repetition. So if you look at that word automobile, notice that the letter O appears twice. So that's what I'm talking about when I mean repetition. So how many different 10-letter arrangements are possible using the letters in the word? So there are 10 letters, all right, but I'm only going to choose 8. All right. So this is going to be 10 factorial divided by 10 minus 8 factorial. So I'm actually going to choose, still comes out to be a big number. This is how many ways you can arrange them. Alright. So here's another way to think about it. So how many different 9-letter arrangements are possible? So notice that this letter appears twice. This letter also appears twice. So this is going to be 9 permutation, and then we're going to choose 5. So this is going to be 9 factorial over 9 minus 5 factorial, which equals this number. Okay, that's really boring. Let's move on. Alright, so combinations are something that you should be pretty familiar with. So combinations are a group of objects in which order doesn't matter. So this is going to be more random than a permutation would be. So here's the formula. It's going to be n factorial divided by r factorial n minus r factorial. And n still stands for the number of objects available, and r is how many you want to use for the arrangement. And then if you ever have n choose n, it's always going to equal 1. So let's do some examples, because I know that really doesn't make sense. So Natalie has 16 close friends. How many ways can she choose 5 people to be her bridesmaids? So there's no order to the bridesmaids, it's just 5 bridesmaids. So it's going to be a combination, and she's going to choose 5. So 16 factorial over 5 factorial, 16 minus 5 factorial. And if you do all this, you get 4,368. Okay. There are 24 students in Kyle's kindergarten class, 24 total. How many ways can he choose 8 to attend his birthday party? So he's not choosing first place, second place, order doesn't matter, he's just choosing 8. So it's going to be 24 factorial over 8 factorial, 24 minus 8 factorial. So this is how many ways he can do that. That's a lot. Alright, Abby is adopting 2 kittens from the pet store. There are 18 kittens total, and she's only going to choose 2. So 18 factorial, 2 factorial, 18 minus 2 factorial, 153. Right? There are 12 employees at the sub shop. How many ways can the manager choose 4 for the Sunday evening? There are 12 altogether. He's only going to choose 4. So 12 factorial over 4 factorial, 12 minus 4 factorial. So 495. And then the last one, there are 85 players on a football team. The coach is just going to choose 3 to represent the team in the coin toss. So it's going to be 85 factorial over 3 factorial, 85 minus 3 factorial. 98770. Okay, so here's what I'm going to tell you. The ones about repetition, like this one back here, don't worry about those. I just wanted to show them to you because if you take some college level math courses want you to know that, but you don't have to do that. So if you understand the difference between a permutation and a combination and you understand the formula and you know how to use it, then really that's all that matters. So let me know if I can help in any way, and yeah, just send me a message if you need help.